Hello, I'm Wayne Lack and I'm going through all of June 2013 AQA Core 3. This is question 2. The whole paper will be on my channel if you're not in the playlist already. So question 2, according to the examiner's reports, most people actually got it right. I think the reason for that is that because people know that differentiation is going to be quite tricky, people revise it a lot, but there was some common sort of errors, just mathematical errors, as opposed to not knowing what to do. But we're going to go through it anyway, so let's turn to the whiteboard and go through question 2. So question 2, there's part A, there's part B, just like in question 1. So A, given that y equals x to the power of 4 tan 2x, find dy by dx. So it's simply asking you to differentiate x to the 4 tan 2x. So you can see that it's in the form uv, there's one multiplied by the other. We're going to be using our product rule, so our formula for dy by dx is equal to u dv by dx plus v du by dx. And it doesn't matter which of the two of the products we let be our u and which we let be our v, it will be the same either way, but I'm going to say u equals x to the power of 4, so therefore our v is the other one, tan 2x. We differentiate both to get du by dx equals 4x cubed from our simple core 1 differentiation, but then dv by dx is a little bit trickier. Now differentiating tan x gets sec squared x, so differentiating tan 2x gets 2 sec squared 2x. And then we can apply this formula. We now have our u, our v, our dv by dx and a du by dx. So u is our x to the 4, so it's x to the power of 4 dv by dx, which is 2 sec squared 2x, plus v du dx, so v is tan 2x, and our du dx is 4x cubed. Now I think it's probably clearer to the examiner to flip it round, because in a multiplication it doesn't matter which way round it is, so I'm going to rewrite that with the 4x cubed in front, because I just think that looks a little bit neater. 4x cubed tan 2x. You wouldn't get penalised being the other way around, I just think that looks a little bit neater. So that would be your final answer, and you look at these sorts of things and think, does that look right? And the answer is no, it doesn't. They look hideous, but that is the answer. Part B, find the gradient of y equals x squared over x minus 1 at the point x equals 3. So to find the gradient of a curve, because this is some sort of curve, I don't know what it looks like, but it's some sort of curve. To find the gradient of a curve at the point, first we must differentiate it. So this is sort of knowing what differentiation is to be able to, in order to do this question. And again, we can see that it's in the form y equals u over v. Now it matters which way round it is in this case. The u is the numerator, the v is the denominator. So our dy by dx, there's another formula for this one, it's v du by dx minus u dv by dx all over v squared. That's our formula for this. So like I say, it matters which way around it is this time. So u is the numerator, which is x squared, and v is our denominator, which is x minus 1. Then we differentiate them both. Du by dx therefore must be 2x, there's an equals there, is 2x from our core 1, and dv by dx is 1 from our core 1 differentiation. Now we can go ahead and apply the formula, because we have all four things. So v du dx is v times that one, so it's that times that. So it's 2x lots of x minus 1 minus, and then u dv dx is that one times that one, which is, well, I can do that straight away, x squared times 1 is just x squared. All over v squared, so it's this one squared. All of it, don't forget, x minus 1 is all squared. You can simplify that. The 2x times the x is 2x squared, minus x squared is just the 1x squared. And then you're going to have minus 2x and that's over the x minus 1 squared, which we don't need to bother expanding because we're just going to plonk a number into it, so I think we can leave it like that. Then we put in at the point x equals 3, so substitute 3 for all your x values, you get 3 squared minus 2 lots of 3, all over 3 minus 1 is 2, so it's 2 squared, which is 4. 3 squared is 9, minus 2 times 3 is minus 6, so it's 3 quarters. You can leave it like that, or 0.75 would be accepted. So that's your final answer. In terms of marks, this was 3 marks, this was 3 marks, so the entire question was out of 6. In terms of things people might trip up on, is firstly forgetting these formulas. These formulas for the product rule and the quotient rule are vital to remember, and they're easy marks once you've got them. This one, not many people tripped up on if they had it according to the mark scheme, but some people forgot that. This one, a few people didn't even start. Find the gradient at a point always means differentiate it if it's any sort of curve, and then plonk in your x values, so that's how to do it. Then some people forgot the formula, which again, it's vital to remember. And people who did remember the formula sometimes got them mixed up, which was on top and which was on the bottom, so they actually got the formula slightly wrong. But the more common part was actually right at the last hurdle, was this adding, well, taking away and dividing by 4 at the end there. Some people expanded the bottom to get x squared minus 2x plus 1, but they did it wrong and got it slightly wrong, so it's just arithmetic errors was the most common thing on this. Because it's differentiation, I would advise you revise it a lot because it's likely to come up just like this in your exam. I don't think I've seen an exam where they don't do anything on differentiation, that would be bizarre. So it's worth learning, and that was question 2 of June 2013. Hope it was helpful. I'll see you at question 3.